Hello, grade sevens. I got asked a question in the discussion forum on when you're subtracting integers with chips, whether or not you need to always add zero pairs. And the answer to that question is no. It depends on what the circumstance is. Now, I thought it might be more helpful because I suspect a lot of people are having difficulty with the integer subtraction with the chips, and if you are, this is pretty normal. But I thought I'd do something a little different this time around, in that I'm going to write down a list of steps to carry out to determine whether or not you need to deal with the zero pairs, and then I'll use these steps more specifically to a few examples that I'll get into on the next slide. So maybe people would find it more helpful if they just had like a list of steps they should carry out to determine how they should subtract the integer chips. Let's say we start off with this, that we have integer 1 minus integer 2. So I'm just going to call them some generic integers right now instead of like assigning value to them. Although this could be like, for example, you could have like -5 could be like integer 1, and then -2 could be integer number 2. I'm just going to call them integer number 1, integer number 2 for now. So the steps. Step 1 would be write a statement telling you what to do with the chips. And the statement always goes into this exact format. Starting with integer number 1 chips. So you'd look at integer 1, and if it's a positive integer, that's going to be red chips. If it's a negative integer, blue chips. Then you want to remove integer number 2 chips. Integer number 2, again, if it's a positive integer, red chips. If it's a negative integer, it would be blue chips. So for the example I gave at the top here, -5 subtract -2, the statement would be starting with 5 blue chips, subtract 2 blue chips. Step 2, if you can actually carry out the statement, then go ahead and do it. So some of the problems, you can actually just simply remove the number of chips right away. And if you can, you're done. You don't have to do anything else. You don't need to worry about the zero pairs. The time when you need to worry about the zero pairs is if you cannot carry out the statement. And usually the reason you can't carry out the statement is because the statement will tell you to remove red chips, but you don't have any red chips. So that's when you know you're going to need to deal with the zero pairs. So let's go to step 3 now. Step 3, identify how many red or blue chips you would need to add to carry out statement 1. So you kind of ask yourself, why can't I carry out this operation? And usually the answer to that would be, it's because I don't have this number of chips, or of blue chips, or I don't have this number of red chips. So what you want to do then is you want to say, okay, I could carry out the operation if I just had this number of chips. Once you identify that number of chips you would need to add, that is going to be the exact number of zero pairs that must be added. So you do that and then carry out statement 1. Now, I realize that statements 3 and 4 are really confusing. So what I'll do is I'll just go through 3 examples, and then I'll keep just going back and forth between the 2 different slides showing you how I'm actually going through these steps. All right, so here's what I've got. I have -5 subtract -2 is the first one. So step 1 tells me turn that into a statement telling me what to do. So that would be starting with -5 is blue chips, starting with 5 blue chips. Remove 2 blue chips. So let's draw that. Get my blue chips in here. I've got 5 of them. So I'd have 1, 2, 3, 4, 5. Okay, so I've done step 1. Starting with 5 blue chips, remove 2 blue chips. Step 2 says if you can carry out the statement, then just do it. Well, look, the statement's telling me starting with 5 blue chips, take away 2 of them. So I can go ahead and do that. Just remove 2 of these blue chips. Put a cross through here, put a cross through there. What am I left with now? I'm left with 3 blue chips, which has a value of -3. Therefore, my answer would be -5, subtract -2 would be equal to -3. So in this example, I didn't need to deal with the 0 pairs because I actually had chips that I was able to remove. I could do it. Now let's go to B, where this is not going to be the case. So for B, I have +4 subtract -3. So that would tell me starting with 4 red chips. +4 is red. Remove 3 blue chips. Okay, so let's draw this. Starting with 4 red chips. 1, 2, 3, 4. Starting with 4 red chips, can I remove 3 blue chips? No, because there are no blue chips. So step 3 says, so if you cannot carry out the statement, continue to step 3. Step 3 says, identify how many red or blue chips you would need to add to carry out statement 1. Okay, so what it's telling me is starting with 4 red chips, remove 3 blue chips. To carry out the statement, I would need 3 blue chips to remove. So let's identify. We could carry out the statement if you just added 3 blue chips. So I've identified, in order to carry out the statement, I must add 3 blue chips. If we go to step 4, it says, for however many red or blue chips you need to add, this is the number of 0 pairs to add. So if I identified, I could complete this statement if I could just add 3 blue chips. So I need to add 3 blue chips. That's going to be the number of 0 pairs to add. You can't just add the blue chips on their own. If you added 3 blue chips, that would change the value of the original integer. By adding 3 0 pairs, it's a clever way of introducing the chips I need without changing the original value of +4. So let's go ahead and let's add these 0 pairs. So we're going to add 3 of them. 1, 2, 3. That's the positive part of the 0 pair. 1, 2, 3. Okay, so I've added 3 0 pair. I'm just going to box this and clarify that. Okay, so I've added 3 0 pairs. After I've done this, now I go back and to the starting statement. Starting with 4 red chips, can I remove 3 blue chips? Yes, you now can, because you have these blue chips. So you remove this one, and this one. And what are you left with now? You're left with 7 red chips. 7 red chips has an integer value of +7. Therefore, my subtraction statement would be +4 subtract -3 is equal to +7. So let's just clarify what I did again. So I started off the original statement. Starting off with 4 red chips, remove 3 blue chips. That was step 1. Step 2 says if I can actually do that, do it. But you can't. If you start with 4 red chips, you didn't have the blue chips to remove. So I identified in order to carry out the statement, I had to add 3 blue chips. The number of chips you add is going to be the number of 0 pairs to add. So I had to add 3 0 pairs, and then I can complete the statement and actually figure out what the difference of these integers is going to be. So let's do one more here. So you have -2 subtract -6. So turning this into a statement would be starting with 2 blue chips, negative integer is blue, remove 6 blue chips. Okay, so let's draw those chips. Starting with 2 blue chips, I want to remove 6 blue chips. Can you do that? If you start with 2 blue chips, can you remove 6 blue chips? Kind of. You can remove some of them. So what we could do is right now you could remove 2 of the 6 blue chips. The problem, though, is you don't have enough blue chips to remove. I only have 2 to remove. I need to remove 6. So how many blue chips would you need to add to do this? Well, if you have 2 and you need to remove 6, then you need 4 more blue chips. So I would say add 4 blue chips. The number of chips you need to add to complete the statement is going to be the number of 0 pairs you need to introduce. So we're going to add 4 0 pairs here. Okay, so let's add these 0 pairs. Going to blue. 4 0 pairs, let's draw the blue chips first. So 1, 2, 3, 4. Let's go to the red ones. 1, 2, 3, 4. Let's highlight what we did here. Oops. Sorry, it's not doing a very good drawing a straight line here. Okay, so what I've done here is I added 4 0 pairs. And now can I complete the statement? Starting with 2 blue chips, can I remove 6 blue chips? Yes, you can, because you can now remove 1, 2, 3, 4, 5, 6. And then what are you left with? You're left with 4 red chips. 4 red chips has an integer value of +4. So I wrote the subtraction statement down. The subtraction statement would be -2 subtract -6 is equal to +4. Okay, so I hope by being more specific, by identifying steps, it's clarified to you when you do need to add the 0 pairs or not. So again, you don't always have to add them. You only have to add them if you cannot complete the statement, the initial statement that you write. And then you'd ask yourself, well, how many chips did I need to add to complete that statement? And that's going to be the number of 0 pairs you add. Again, the reason you're adding the 0 pairs is because it's a clever way of introducing the chips that you need without changing the value of the original integer. Okay, so if you weren't able to get those problems, I would just go back and give it a shot now. And if you're still having some issues with dealing with the chips, then just send me another message in the discussion forum, and I'll see what I can do. But hopefully this helps out. Talk to you later.